Hi everyone, this is Rohan, and in this video I am going to demonstrate to you how to find the slopes and deflections in statically determinate structures using Castigliano's theorem. Come, let's learn. Now, as you all might know that there are two Castiglianos theorems, out of which we are going to use Castigliano's second theorem. It states that in a linearly elastic structure, the derivative of strain energy U in terms of internal forces with respect to any force Pi at coordinate I is equal to the deflection delta I at coordinate I. Now, the important thing to remember here is that U, that is the strain energy, is in terms of internal forces. Now, as we all know, there are four types of internal forces: axial force, shear force, bending moment, and twisting moment. But in a rigid jointed frame, the effect of bending moment is predominant compared to the other internal forces developed. That means bending moment has a much bigger influence on rigid jointed frame than compared to axial force, shear force, and twisting moment. So therefore, while trying to find the slopes and deflection in statically determinate structures using Castigliano's theorem, we only consider the strain energy due to bending moment. So the strain energy due to bending moment M acting on a structural element of size dx of modulus of elasticity E and I is given by U is equals to integration m square dx divided by 2EI. Now, if I simply put the value of U, if I simply put this value of U in this above equation, I will get that delta is equals to integration m dm by dp dx divided by EI. Okay, this formula is extremely important for us, and note it down because this is the formula that we are going to use to solve our problem. Now, speaking of the problem, let's directly jump into it. Okay, so this is the problem that we are going to solve today. Now the question is, for the rigid jointed frame A, B, C as shown in figure, calculate the horizontal deflection at C and the rotation at A. Okay, so here we have a frame A, B, C where there is a hinge support at A and there is a roller support at C. The member AB is 5 meters long and the moment of inertia is I, and the member BC is 6 meters long and the moment of inertia is 2I. On the member AB, there is a horizontal load of 40 kilonewton at a point D, which is at a distance 3 meter from support A. And throughout the span BC, there is a UDL of intensity 30 kilonewton per meter. Okay, so now directly before jumping onto the problem, let us just determine some things. Just understand that the degree of static indeterminacy of this structure is 0. The calculations are given here. You can explore it in detail. But the degree of kinematic indeterminacy here is 4, neglecting axial deformation. So what are the 4 different kinematic indeterminacies that are there? Please note here that at C, there is a horizontal movement, or should I say horizontal deflection, theta C. At A, we can have a rotation, let's call that as theta A. At B, we can have a rotation theta B, and at C, we can have a rotation theta C. Okay, so out of this, in this question, we are supposed to find out theta C, and we are supposed to find out delta C, that is the horizontal deflection at C, and we are supposed to find out theta A. We are supposed to find out the rotation at A. The reason why I am telling you is that you can also be asked to find out theta B, or you can also be asked to find out theta C. The procedure will remain the same. So let's see the procedure step by step. So the first step is to find out support reactions. Now at A, there is a hinge support, so the reactions here will be vertical reaction at A and a horizontal reaction at A. support C is a roller support, so therefore there will be only a vertical reaction at C. Since this structure is statically determinate, so therefore we can solve this using the three equations of equilibrium. Let us start with summation of Fx equals to 0, right side positive. So towards the left I have HA and towards the right I have this 40 kilonewton, so I'll have minus HA plus 40 equals to 0. So that will give me HA is equals to 40. Now let's come to summation of moment about A is equals to 0, and let's take clockwise as positive. Definitely HA and VA will not have any moment about A. So let's start with 40. So the 40 will have a clockwise moment about A, and that will be plus 40 multiplied by 3. So here you see 40 multiplied by 3. The next term is going to come from the UDL, that is 30 kilonewton per meter. This is also going to have a clockwise moment about A. So it is going to be 30 into 6, that's the intensity. And if you see the CG of this UDL is going to pass through half of 6, that is 3. Right? So therefore we have 30 into 6, that is the intensity of the load, and the CG is at a distance 3. Okay, so that is why we have 3. Lastly, this VC will have an anti-clockwise moment, so it is minus VC, and the perpendicular distance between line of action of VC and A is 6 meters. So minus VC into 6. So if you do the calculation, you will get VC equals to 110. Lastly, if you apply summation of f of y equals to 0 upwards as positive, we have VA in the upward direction, so plus VA, minus 30 into 6 in the downward direction, and again plus VC, but here we know the value of VC, that is 110, so I can directly write plus 110 equals to 0. So if you do the calculation, you get VA is equals to 70. Now since all our values have come as positive, so therefore our chosen direction of the reactions are correct. So I can simply write it like this, or I can show it in the figure like this. So 70 kilonewton in the upward direction, 40 kilonewton towards the left hand side, and 110 kilonewton towards the upward direction. Now pay attention to step 2. Step 2 is to find bending moment due to the given loading. Okay, now when the topic comes of bending moment, let me just take a moment to tell you what is bending moment. Bending moment at any section is the algebraic sum of all the moments of all the forces either to the left or to the right of the section considered. And in order to find that out, we need to always remember the sign convention of bending moment, that is left of the section clockwise moment and right of the section anti-clockwise moments are taken as positive, and left of the section anti-clockwise moment and right of the section clockwise moments are taken as negative. So this is important for us to remember. And in this problem, if you see, I cannot find out the bending moment of the entire structure at once. I will have to divide the structure into regions. So here I am going to divide it into 3 regions, right? And correspondingly I am going to write down all of these values. So you can prepare this table and go on with finding out the moments. So the first region that I'm going to consider from the left hand bottom side is AD, Now if I write the value of I, the value of I is simply I as given in the problem. Now we want to write a general bending moment equation for the span AB, So for that, what we do usually, we take a random section, right, at a distance x from A, and we are going to find out the bending moment at this point, okay? So for that, what will be my origin? My origin will be A, because that is where I have started this x. So my origin will be A. Now what is the limit? What is the limit of x? See, x spans from A to D, because this is the region AD. At A, the value of x is 0. So the lower limit is 0. 2. And it spans up to D. The upper limit of x is then D. And D is at a distance 3. So 0 to 3. Okay. Now let's find out the bending moment. Here, left of section, only one force is there, 40. Obviously, this 70 will pass right through this point, so no moments. So 40 right? And it is having a clockwise moment. So left of section clockwise moment is positive. So 40 multiplied by x. So let me write this as 40 multiplied by x. That's your bending moment at this region. Now let's consider the next region as dB. dB. For this region also, the value of I is I. And in the definition of bending moment, I told you, you have to take the bending moment of all the forces either to the left or to the right. So now when I take all the forces to the left, so therefore in this case while cutting the section, I will have to take the value of x again from A, because I have to consider all the forces towards the left. All the forces, I cannot start from D, then this load will go missing, right? So therefore I'll have to start from A itself. Okay, so my origin is again A, but the limit will not be the same. I'll explain to you. Now the limit of x here, it will start at D and it will end at B. Okay, but at D the value of this x, now you please consider only this blue color x, not the red color x. This x, the value of x at D is 3. So the lower limit here will be 3 and the upper limit, that is at B, will be equals to 5. So the limit is 3 to 5. Okay, now let us start finding out the moments. Now again, the first moment will be due to this 40 kilonewton. This 40 kilonewton multiplied by this x, so that is 40x. And now let's consider this 40 kilonewton, and we are trying to find out the moment here. Okay, so there we need to find out this distance. What is the distance between this 40 kilonewton and that place? So how do we find that? This entire length is x, and up from A to D it is 3. So therefore this much must be the total length x minus 3. So this distance is x minus 3. And please consider that this 40 kilonewton will have an anti-clockwise moment. So left of section anti-clockwise is negative. So here I'll have minus 40 into x minus 3. Okay. So here if I want to simplify, 40x minus 40x will become 0, and minus 40 into minus 3 will become equals to 120. Okay, that's just the simplified way of writing this. The third member, let us take BC. Now I have the choice whether to take left of section or right. But if you see from left of section, there will be multiple loads. But if I directly go from the right of section, there is only this point load and a part of the UDL. So let me take the section now from right of the So here the origin will be C. I just forgot to write one thing here, students. The value of I here for BC is 2I. This is important. The value of I is 2I. Now let us take the section from C. And what is the limit of x? C to B. So at C, the value of x is 0. And at B, the value of x, if you see, it's equal to 6. So the limit is 0 to 6. So now this force, right of section anti-clockwise, that is positive. So positive 110 into x. So let me write this as 110 into x. Minus, please see, only this part of the UDL has to be considered. So it is minus 30 into x by 2, because the CG will act at x by 2. 30 into x by 2. So if I wish to simplify that, I can write that as 110x minus 15x square. Okay. So this is how you make the table, and just here I have just rubbed all those calculations and I have simplified this so that you can look at it properly. So this is how you find out the bending moment due to the given loading in a frame, taking different regions and taking the sections. Now let us move on to step 3, a very important step. So please pay attention. Let's go one by one. So here it says to find the horizontal deflection at C. So now you see we are finding out the horizontal deflection at C. So first thing that we have to do is remove the given loading. So given loading, this 30 kilonewton has to be removed. So I am removing that. Second, this 40 kilonewton also needs to be removed, so I am removing that. So students, you need to draw a different figure here, okay, because you will need to remove these two loads and you have to apply a dummy load P at the point C in the horizontal direction. So like this, at P you have to at the point C you have to apply a load P in the horizontal direction. Now the question may arise, why horizontal direction? Now, suppose in some random problem you had to find the vertical deflection at B, then you would have to apply a dummy load P at the point B in the vertical direction. So are you getting it? If horizontal deflection is asked, give horizontal load. If vertical deflection is asked, give vertical load. Okay, vertical dummy load, horizontal dummy load. Now, another question that may arise is whether to take this towards the right or towards the left. And the answer to that question is, it does not matter. You take any side. At the end of the problem, automatically the sign convention will tell you whether the deflection is happening towards the right or towards the left. So we will come to that later. So the answer is, it doesn't matter. Horizontal is all that matters. Left or right, it doesn't matter. Okay, so now we will start by finding out the support reaction. Again, you know, three reactions will be there: VA, HA, and VC. Again, the procedure remains the same, that is equations of equilibrium. Summation of Fx equals to 0. If I take, then I will have minus HA plus P equals to 0. So from that, I'll get HA equals to P. Next, summation of moment about A equals to 0, clockwise positive. We have two loads, P, which will have a clockwise moment, and the entire height is equals to 5, and minus this VC will have an anti-clockwise moment, and sorry, here it is written as VB, it will be VC. Okay, I'll just make this quick correction here. This should be VC. VC into 6 here will be equals to 0. Okay, so now here, so if I do the calculation, so VC becomes 5P by 6. And lastly, if I do summation of Fy equals to 0, VA, that is this VA plus VC, now we note the value of VC is 5P by 6 equals to 0. So VA is equals to minus 5P by 6. Pay attention here. HA is equals to P. Now, HA is, the value of HA is coming as positive. The value of VC is also coming as positive, but the value of VA is coming as negative. What does this mean? This means that our chosen direction of VA is wrong. So we thought that it is in the upward direction, but actually VA is in the downward direction. So you can either show it like this, like VP by 6 in the downward direction, HPP equals to in the left, and VC VP by 6 in the upward direction, or you can directly show it in the figure. VP by 6 I'm putting in the downward direction, HA towards the left, and VC towards the upward direction. Now here again, we have to find the bending moment, but now we have to find the bending moment due to the dummy loading, and moreover we have to derivate that bending moment with respect to the dummy load. So let's take it slow and let's take it one by one. For this purpose, I will bring back the table. This is already there with you, students, so you do not need to draw it again. Okay, this is already with you. These columns now we are going to fill. Okay, now you see, since we are using this table, so therefore our previous sections that we had drawn, okay, that will also be the same. So I have brought those back, okay, the sections as it is, because all those above things are the same, and here I have simply pasted the sign convention for our convenience. So now I am going to find out the bending moment due to this dummy load. So now let me call that as MP, since the name of our dummy load is P. So let the moment due to that be MP. Now look at this part now, AD. So we are finding out the bending moment at this point. So we have only one load P and this distance is X. So here I will have P into X. Okay. Now, if you look at DB, Okay, now we are finding out the bending moment at this point. But now our x is this one. X is this one. Okay. Forget this x for now. Forget this x for now. Okay. Our x is this one. Still, if you notice, the only load there that exists is P. So it will be P into X. So it will again be P multiplied by X. Now come to section BC. We are taking right of section here. So we have 5P by 6, right? And the distance is X. And right of section anti-clockwise is positive. So let me take that as 5P by 6 into X. Okay. So this is how you find the moment. Now you have to moreover derivate it. So it will be dmp, and with what respect you have to derivate it? You have to derivate it with respect to the dummy load. What is our dummy load? P. So dmp by dp. So if I do the d by dp of px, p will be gone, only x will be left. Similarly here, p will be gone, only 6 will be left. Similarly, d by dp of 5px by 6 will be 5x by 6. Alright, so now step number 5 is find deflection at C using Castigliano's formula. You recall at the beginning of today's lecture, we had given you this formula, right? And using this, we will be finding out the deflection at C. Now for that, again, we will be requiring this table. Don't worry, this is the same table, only thing I have written it in PPT, not in pen. Okay, so now let's see how one by one you can take this the terms from this table, okay, and use it here. If you see M, this is your M, okay, this is the M. So all values are of M we are going to take from this row. And if you see the next term, dmp by dp, okay, this is that row. Okay, so these are the two rows from where we are going to take the values. So let's see one by one. We have to do this region by region and add it. So E is equals to integration for the part AD, the limits is 0 to 3. The value of M is 40x. Can you see here? The value of M is 40x and the value of dm by dp is x. So it will be 40x multiplied by x dx, and the value of I is I only, so divided by EI. Simple. Plus, now for the portion dB, integration. Now the limit is 3 to 5. Limits is 3 to 5. Okay. The value of M is 120 and the value of dmp by dp is x. Value of M is 120. And the value of dmp by dmp by dp is x. So again, 120 into dx divided by EI. The value of I is still I. Plus, for the portion BC, integration, the limits is 0 to 6. The value of M is 110x minus 15x square. The value of dmp by dp is 5x by 6 dx. Now be very careful here. A lot of students make this silly mistake. The value of I is now 2i. Okay, so therefore EI will become 2EI. 2EI. Now, so I hope this is clear to you. And this you can simply put in your calci now and get the answer. So the calculator that I am currently using and also highly recommending to my students is this Casio FX991EX ClassWiz non-programmable scientific calculator. And the reason why I'm recommending is that first of all, it is non-programmable, so therefore it is allowed in the exam. And second of all, if you just see this visual, okay, this is exactly how I wrote the previous equation, right, in the previous slide. So therefore the visuals in this calci is such that it is exactly like how you write in your notebook. So therefore the chances of making mistakes are very less. So therefore it becomes a very handy tool. Now before I move on from this topic, I need to clarify this is not a paid promotion. Casio is not paying me for this, but if you need to buy the product, the link is in the description. By all means, go ahead. Now, coming back to this problem, you see the answer is already available us, that is plus 2595. So therefore, I will write the answer now is equals to 2595, and let's not forget divided by EI. In some problems the value of EI may be given. Here it is not given, so we will keep it as it is. So what we got that the value of theta c is equals to 2595 divided by EI. Now the important thing here to understand is that the value has come in positive. Therefore, our chosen direction of the dummy load is the actual direction of this deflection, that is towards the right. Now, if this answer would have come as negative, then the meaning is that our chosen direction would have to be changed to the opposite. You do not need to resolve the problem. Simply here, you should have written towards the left if you would have got the answer in negative. Okay, now let's find out the slope or rotation at A. Now, students, you will notice that after step 5, I've gone back to step 3 because this is a repetition of step 3, 4, and 5. Okay, so you will find quite a lot of similarities here. So to find the slope or rotation at A, again, we have to remove the given loading. So let's remove this 30 kilonewton per meter and this 40 kilonewton per meter. But now, since you're asked to find the slope or rotation, you will have to apply a dummy moment P at A. So here I'm applying a dummy moment P at A. The question may arise whether to take it clockwise or anti-clockwise. The answer is it does not matter. You can take anything. Okay. Suppose I have taken clockwise here and my answer comes in minus. The final answer comes in minus. That means the rotation will be in the anti-clockwise direction. If it comes plus, then it means it is the clockwise direction only. So it's as simple as that. So let's move on to the next step, that is to find out the support reaction. 3 reactions, VA, HA, VC. How do we find equations of equilibrium? Summation of Fx, only one load HA. So therefore HA is equals to 0. Then summation of moment about A is equals to 0. So here pay attention, HA and VA will have no moment at A, but P is there. P itself is a moment. So P will be there, and minus VC multiplied by this distance 6 is equals to 0. So therefore VC is equals to P by 6. Again, summation of f of y is equals to 0. So we have VA plus VC, the value of which is P by 6, is equals to 0, or VA is equals to minus P by 6. Now what does this minus mean? It means that our chosen direction of VA was wrong. VA is actually in the downward direction. HA is anyway 0 and P by 6 is in the upward direction. So I will choose to draw them like this. So P by 6 I am drawing in the downward direction. HA is not there. HA is 0. So I am not going to even draw HA. And VC is in the upward direction, P by 6. So now in step 4, what do I have to do? I have to find the bending moment due to the dummy moment and derivate it with respect to the dummy moment. So let's see what we got here. We have to again bring back this table. I hope you all remember this table. And since we are bringing back this table, so let's also bring back the sections that we had drawn. So it's the same sections that we have to bring back again, and I'm just going to leave the sign convention here. So now let's find out the moments due to the dummy bending moment due to the dummy moment P. So let's call this as MP again, right? And now let us first find out the bending moment in the section AD. So if you see, we have a clockwise moment. We have a clockwise moment of P, and clockwise left of section is positive. So it will just be P. If you see in between D and B, right, there are no loads here, only again this clockwise moment P. So again, I will have to have a P. Okay. Now let's come here at BC. From C, I'll have to C. So here we have P by 6. Again, it's going to have an anti-clockwise moment. Right of section anti-clockwise is positive. So P by 6 multiplied by X. So P by 6 multiplied by X. Now let's derivate this with respect to P. So d by dp of p is 1, d by dp of p is 1, d by dp of p 6 into x is x by 6, x by 6. Okay, all right. So last step here, that is find rotation at A using Castigliano's formula. This formula you are already aware of, right? And for this, we need to take the help of this table. This is just the previous table you saw, just I have written it in proper computer fonts. Now, just one by one, let us take the terms here. Let us take the terms and do this. So here again, I am going to take this row, values from this row and this row, right? So I will have here is equals to, for the first region AD, I will have 0 to 3. Value of M is 40x. The value of dmp by dx is 1. dx divided by EI. Plus, for dB, it is 3 to 5. The value of M is 120 and the value of dmp by dp is 1 dx, and this is divided by EI. Plus integration. Now for BC, this is 0 to 6. The value of M is 110x minus 15x square. The value of dmp by dp is x by 6 dx. Very careful. Here the value of EI will be 2EI. Again, simply put this in the calci, okay, and you will get the answer as plus 675. So here it will be plus 675 divided by EI. What does the plus sign indicate here? The plus sign indicates that the chosen direction is correct. So 675 divided by EI will be in the clockwise direction. Our chosen direction of dummy moment was clockwise. So this is our answer. So in conclusion, this was the rigid frame that was given to you, rigid jointed frame, and you were asked to find out the value of deflection at C, horizontal deflection at C, and you got the value as 2595 divided by EI towards the right, and you were asked to find out the rotation at A. So you have got the value as 675 divided by EI in the clockwise direction. Now, students, if you have any doubts, definitely you can write it in the comments below. Now, what I would like from you to write in the comment below is, if you have really understood this video, please find out the value of theta B, okay, and find out the value of theta C. And it will be really cool if you can solve this and write the answers in the comments. I hope this video was useful for you. Thank you for your time.